All right, so last time we started our discussion in section 4.1 of exponential functions, and today we're going to do the part that's the and their applications. The primary application we're focusing on, because it is actually quite important, is compound interest. So compound interest has the equation A equals P times 1 plus R over N to the NT. Each of those letters is a specific quantity. P is called the principal. It's the amount of the loan or the deposit. So the loan if you're borrowing money, a deposit if you're investing. T is the length of the time of the loan. It's always in years. So if they give it to you in months, you got to turn it into years. So sometimes you'll see things that are written as 18 months. Well, you need to know that T would equal 1.5 then, because that's a year and a half. Or sometimes you'll see 36 months, 3 years. R is the annual interest rate as a decimal. So the rate's always given to you in a percentage form, so say like 5%. So you have to turn that 5% into a decimal by shifting the decimal point 2 decimal places to the left. And then N is the number of times it's compounded every year. So N will fluctuate. Basically, you have to figure it out. So annually would mean 1 time a year. Biannually would mean 2 times a year. Yeah. So quarterly would be 4 times a year, 4 quarters in a whole, right? Monthly would be 12 times a year. And those are the most common ones in a practical sense. You might also see used things like daily, which would be 365 times a year. Not quite as common in practical life, but you sometimes will see problems written that way. And then A is the amount that you have or you owe if you're doing a loan after T years. So there's one more, and this is called continuously compounded. So continuously compounded means that it's continuously compounding. So there isn't an N that actually makes sense for that since it's doing it on a continual basis. This equation looks a little bit different. It's A equals P e to the RT. P is still the principal, R is still the interest rates, T is still the time in years, A is still the amount that you have afterwards. The E is actually the E in your calculator. So an approximation for it is 2.718, but your calculator will have the exact value. It's irrational, like the number pi. So we want to use the exact form that the calculator would have in it, because at the very least, the calculator has way more decimals than that 2.718 would have. All right, so we're going to do an example. The example we're going to do is an investment of $80,000 at 4%. And it's going to be at a rate of, or for a time period of 20 years. And then the different parts to this, A through E, are telling you how it's being compounded. So parts of this stay the same. For example, this 80,000 is always P. The 4% is always R, but you have to turn it into a decimal. So if it's 4%, what is that as a decimal? Yep, 0.04 or 0.04. And then the rate, or the time, excuse me, is 20 years, so this is T. So those 3 pieces are going to stay the same no matter which of these 2 equations, this one or this one that we use. The thing that's going to change is, in particular, which formula we're going to use potentially, and then also what the N value is if we're using this one. Okay? So I've already got that other one written here, so A equal P e to the RT. Let me actually write on the same screen the other one so that I'm not flipping back and forth all the time. So it is A equal P times 1 plus R over N to the NT. I'm going to put that on the orange because it'll show up a little bit better. Okay, so those are my 2 equations. All right, so the first one, part A, says annually. So which of the 2 equations am I going to use if it's annually compounded? Let me number them. We'll call this equation 1 since it was on the first slide, and we'll call this one equation 2 since we put it on the second slide. Which of those 2 equations should we be using if it's annually compounded? 1. Okay, so every single time we're going to be using equation 1 unless it says continually. If it doesn't say continually, it's equation 1. So this is A equals, the P is the 80,000. I have 1 plus my R was 0.04. Over N. What is N if it's annually compounded? 1. Yeah, it's 1 time a year. So over 1 to the nt, which would be 1 times the t, which is 20. The one thing that can happen in your calculator to be cautious of here is that if you enter this with the parentheses that are sort of showing on my screen right here, on this one it won't matter because well, actually it probably would. Your exponent 1 times 20 needs to actually be simplified. If you put this into your calculator, most of your calculators will actually put it in, some of it might allow you to put it in the form that it actually shows, but a lot of them, like mine or like a basic scientific calculator, if you put it in like this, it's going to look like this. There's a multiplication. I'll just put a dot. So it'll look like this. And what your calculator thinks you're doing, if you put it in like this, is that you're raising all of this to the power 1, and then you're multiplying that result by 20. But that 20 should be multiplied by the 1 in the exponent, right? So we have to make sure that our calculator understands that. There's a couple of options. One option is to put parentheses around the exponent. You can do that if you wish. What I actually would prefer doing instead is actually just simplifying my exponent every time, because it's usually something that I can do very quickly. 1 times 20, it's 20 as my exponent. I'll have another one here in a moment. It won't be 20 as my exponent, it'll be something bigger, but it's usually something you can compute pretty easily. So your calculator can compute all of this for you, no problem. So you can actually type it in just like this is below, 80,000, parentheses 1 plus 0.04 divided by 1 to the 20. It's money, so we can only have 2 decimal places. So what do you get if you type this into your calculator? Somebody find out for me what you have. What'd you get? Okay, so the number should be bigger than 80,000, but if it's like 80 million, we got a problem. So what number did you get? Okay, so you're close. I'm not sure what's going on. It's not quite right, though, but you're in the ballpark.
I got 175,289.
Okay. Oh, I'm looking at the wrong line on my paper. That's what's wrong. Okay, 289. 85. Then yes, that's correct. Sorry. I was on part B. You're okay. You're good. Sorry, I was looking at my part B answer anyway. So yeah. Okay, so the number is probably going to be a little more than double. It's usually between 2 and 3 times as much when we do this. If it's significantly different than that, you've probably got an error in the way you've input something, or maybe just a typo in general. But this would be our amount. Okay, so when you borrow or you put this investment in at $80,000, it ends up being worth or costing you $175,000 later. Okay? So let's do part B, quarterly. Quarterly means that I'm using, again, the first equation because it doesn't say continually. What is my n if it's quarterly? 4. So I have much the same as what I had before. I have my 80,000. I have 1 plus r, which is 0.04. But now I'm dividing by 4 because n is 4. And I'm multiplying by, I'm raising to the exponent 4 times 20. So again, this is the case where I'm like 4 times 20, I'm not going to type it in my calculator unless you put it in parentheses. I can do 4 times 20 pretty quickly. It's 80, so my exponent is simply 80 instead. So there's 2 things that changed. The exponent changed and the division of the rate changed. Everything else remained the same. And if you put this in, oh, and I needed a dollar sign on my earlier one. I'm so sorry. We do have a dollar amount. What value did we get when we do quarterly? What are your 2 decimal places? Does it give it to you?
Oh,
2 what?
1.
I think the second one probably rounds. What's after the 1? Does it? Okay. Yeah, we'll just use our normal rounding rules. So either 4 and down behind, 4 and lower behind it will round down, and then 5 and up will round up. So I have $177,337.22. Is that good? Okay. I feel like it's like same song, second verse. Right, we're just doing the same thing over and over again for these first 4, actually. Monthly. Monthly means I'm going to use that first equation. and n is going to equal 12. Thank you. 12 months in a year, you bet. So this is A equals, my principal's still the same, 80,000. I have 1 plus R, which was that same 0.04, but now it's over 12 for monthly. And my exponent is 12 times 20. And again, I would simplify the 12 times 20. What is 12 times 20? 240, right? So my exponent will be 240, and the division will be by 12. Now notice, the more we compound, the numbers are going up. So we went from 175,000 to 177,000, right? So our expectation is that we should have something bigger than 177,337.22. So what do we get for the third one, monthly compounding? Okay, that's what I have too. Very good. Okay, it's bigger than the number before. Now, it didn't jump up quite as much as it did the last time, but it is bigger than it was before. How about daily? We're 365, so we're ignoring the whole leap year bit. It doesn't affect it enough to actually change values, so there's no sense in sort of messing with the context with that. We do have 80,000 still. I still have 1 plus my rate, which is 0.04. I'm dividing now by 365, though. And my multiplication on my exponent is 365 times 20. And that one you might not do in your head, but your calculator can do it just fine either way. What is 365 times 20?
7,000.
Not 7,700.
Oh, 700. I got 700.
Oh, sorry. I was thinking times the 2, and I was going to put my 0 on the end. You're right, 7,000. What did you get? Sorry, go ahead, Brady.
300.
7,300. Do I have a second on that? Yeah? Okay, good. Sorry. I was doing the 2, and then I was going to put my 0. You were doing it all at once. Apologize. Yeah. So 7,300 for my exponent. So that's my new exponent with the new division of 365. Again, it should be bigger than the last one, which was 177,800. So what does this one become? That's what I have too. Good job. Okay, that everyone's value they got? Seems realistic, right, in the sense that it's slightly larger than the last one, but still close, right, all that stuff. All right, continuously means that I'm changing formulas, agreed? Okay, so I'm actually going to write it down here since we haven't used it. These are 2 formulas that you will want to memorize, okay? So here's the formula for continuously compounded interest. The variables are all the same, so P is still 80,000, so the beginning of it actually looks much like the other one. I don't have the 1 plus R over N, though. I have E. And then I have my rate, which is 0.04 as part of my exponent this time, and my time, which is 20. Just like before, though, it will be much cleaner and easier to work with in your calculator if you go ahead and find the exponent's value first. What is 0.04 times 20? 0.8. So my exponent that we would enter, and I would do it that way anyway, is 0.8, so that I don't have any issues with the calculator's order of operations. So 80,000 e to the 0.8. If you don't know where your e is, let me know so I can come around and show you on your calculator, because every calculator version does it a little differently. Does everybody see where their e is? Not yet? Okay. Else not these? We're all good? Okay, great. And it should be, again, a little larger than the one before, but close. So what did you get for the continuously compounded? 178,000. Yeah. So it's sort of negligibly different considering how large these numbers are, right? $35, the only difference is the $35 compared to the $43 thereabouts, right? It's a little bit more, but not a lot. Any question on the compounding? All right.